Okay, so in this short video, I just want to do an example that is similar to the homework. It's similar to homework 3.1.11. And so the problem is we have a loan of 1,000. The nominal monthly interest rate is 12%. And this loan is repaid in 6 monthly payments. As usual, starting 1 month after the loan is made. So we have loans form an annuity immediate, as all loans in this example form. So the first 3 payments are X, and the last 3 payments are 2X. Find the outstanding balance at the end of the 4th month using both the retrospective and the prospective method. So I should mention that the prospective method it's definitely quicker in this example. And in general, if you're finding OBT for t close to the end of the loan, it's quicker to use the prospective method because there's not many payments you have to deal with in the future. On the other hand, if you're looking for OBT, closer to the loan start, and you have the original loan value, then the retrospective method is quicker because there's just not too many time periods between t and the loan beginning, if the start of the loan, if t is close to the start of the loan. So there's not too many payments you have to deal with. Okay, but I'm asking you to do both. In particular, let's make sure that they give us the same answer, as they better do, obviously. Okay, so let's do this problem. All right. So monthly interest is monthly effective interest. As usual, it's I-12 over 12. Remember, I-12 means we're taking the per 1/12 year interest is whatever this is over 12. Per 1/12 year interest is per month interest. So that's 0.01. So we have the following time diagram. First 3 months payment is X, next 3 months is 2X, for a total of 6 loan payments. Okay. So let's figure out what X is, and we absolutely have to do that no matter which method we use, because both methods require we know some of the loan payments. So we either need to know the 5th and the 6th loan payment to use the prospective method, or we need to know the 1st, 2nd, 3rd, and 4th loan payment in addition to the loan value. We do have the loan value, it's 1,000. It's a $1,000 loan. But either way, we need to know what X is. So let's just set up an equation of value like we've done dozens of times. So these are 2 different payments. So we have to break it up into an annuity, one involving these 3 payments, which the present value is just XA3.01. This is just an annuity, 3 payments of X per monthly interest is 0.01. Nothing to that. And basically the same thing here. The present value at t equals 3 of these 3 payments is 2x a3.01. But we don't want the present value at t equals 3. We want the present value at t equals 0, because we want the present value of all the loan payments. That's going to be equal to 1,000, which is a loan amount, so that we can solve for X. So we discount this by 3 months to get the present value of these 3 loan payments at the beginning of the loan. So you just add these up. Again, this is the present value of all the loan payments, these 6 loan payments. A3, X times A3.01, 2X A3.01 times 1.01 to the minus 3. Taking this, discounting it by 3 months. Okay, So that's the present value of the loan payments. And again, not to sound like a broken record, but by essentially how loans work, that's what the loan amount is. That's the loan value. So dump this into a calculator and dump all this into a calculator to 2a3.01, 1.03 minus 3. We get 8.65x divided by 8.65, you get 1115.61. Okay. So that means that these three payments are 1115.61, and these three payments are 2 times 1115.61, which is 231.21. K1, K2, K3 is 1115.61. K4, K5, K6 is 231.21. Okay, so as I mentioned, it's quicker to do the prospective method because the end of the 4th month is pretty close to the end of the loan. The end of the loan. The end of the loan is at the 6th month. At the end of the 6th month. That is quicker. Let's just do the retrospective method first. So it's just plug and chug. Just plug into my formula like we did before. Not much more to say than that. We know what KL is. First 3 Ks are 115.61. Then it's 231.21. So it's 1,000, 1.04 to the 4th. T equals 4. L is 1,000. We were given, remember that L is 1,000. That's the loan amount. So T equals 1, 4 minus 1 is 3. L equals 1, 4 minus 1 is 3. L equals 2, 4 minus 2 is 2. L equals 3, 4 minus 3 is 1. And L equals 4, 4 minus 4 is 0. K1, K2, K3, 1115.61. K4, 231.21. So we get 455.58. And for the prospective method, just dump into our formula. Yeah, you'll see this is definitely quicker, obviously. T equals 4, N equals 6. 6 minus 4 is 2. So you just have these two terms here. Nu is a present value factor, 1 over 1.01. And after rounding, we get 455.58, as we better. Okay, so that finishes this problem. So we're going to just look at variations of loan situations in the next video. We're going to see how the formulas simplify when we have a loan with constant payments. We're also going to look at a loan with where you, by intention, repay constant amount of principal each period. So yeah, that'll be up in a few days.